Welcome to the Ultimate JMeter Interview and Preparation Guide for 2025. In this video, we'll walk you through everything you need to master Apache JMeter, from essential interview questions to hands-on preparation tips. Whether you're preparing for a job interview or aiming to sharpen your performance testing skills, this guide is designed to give you both the knowledge and confidence you need. Let's start by understanding what JMeter is and why it's such a popular tool in the world of performance testing. Apache JMeter is an open-source tool widely used for performance, load, and stress testing of web applications, APIs, and various services. Its intuitive interface and robust features make it a favorite among testers and developers alike. With JMeter, you can simulate real-world user traffic, analyze server performance, and identify bottlenecks before they impact your users. This flexibility and power have made JMeter a staple in the performance testing toolkit. JMeter isn't limited to just one kind of testing. It supports performance, load, and stress testing, allowing you to evaluate how your application behaves under different conditions. Additionally, JMeter can handle functional testing for certain scenarios and even distributed testing, where multiple machines work together to simulate a massive user load. This versatility ensures that JMeter can adapt to a wide range of testing needs, making it a valuable asset for any QA team. Thread groups are the backbone of any JMeter test plan. They define the number of virtual users, the ramp-up period, and the loop count. In essence, thread groups let you control how many users will be simulated, how quickly they'll start, and how many times each user will repeat the test steps. This setup is crucial for mimicking real-world usage patterns and ensuring your tests are both realistic and effective. Samplers are the components in JMeter that actually send requests to your server. Whether you're testing HTTP endpoints, databases, or FTP servers, samplers handle the communication and collect responses. Common types include HTTP Request, JDBC Request, and FTP Request. By configuring samplers, you can simulate different types of user actions and measure how your system responds to each. Listeners in JMeter are responsible for collecting and displaying test results. They come in various forms, such as graphs, tables, and logs. Popular listeners include the view results tree, summary report, and aggregate report. By using listeners, you can visualize how your system performs under load, identify trends, and quickly spot any issues that need attention. Timers play a crucial role in making your JMeter tests realistic. By introducing delays between requests, timers help simulate real user behavior and prevent all virtual users from hitting the server at the same instant. This not only avoids unrealistic spikes, but also provides more accurate insights into how your application handles concurrent users over time. The ramp-up period in JMeter determines how quickly virtual users are added to the test. A gradual ramp-up helps prevent sudden shocks to your system, allowing you to observe how performance changes as load increases. By fine-tuning the ramp-up period, you can better mimic real-world scenarios and identify the exact point where your application starts to struggle. Parameterization allows you to make your tests dynamic by using different data for each virtual user. In JMeter, this is often achieved with the CSV dataset config or user-defined variables. By reading data from external files, you can simulate a wide range of user behaviors and ensure your tests reflect real-world usage patterns. Assertions are essential for validating the responses your application returns during a test. In JMeter, assertions can check if the response code is correct, if specific text is present, or if the response time meets expectations. By setting up assertions, you can automatically detect errors and ensure your application behaves as expected under load. You need to simulate thousands of users. Distributed testing is the way to go. JMeter allows you to connect multiple slave machines to a master node, distributing the load and enabling large-scale tests. This approach is ideal for stress testing high-traffic applications and ensuring your infrastructure can handle peak loads. Understanding the difference between throughput and latency is key to interpreting your test results. Throughput measures how many requests your server can handle per second, while latency is the delay between sending a request and receiving the first byte of the response. Both metrics are crucial for evaluating system performance and identifying potential bottlenecks. Monitoring server performance during load testing is essential for a complete picture. JMeter can be extended with plugins, or you can use external tools like Grafana and InfluxDB for real-time dashboards. Integrating with application performance monitoring, APM, tools such as New Relic provides even deeper insights, helping you pinpoint exactly where issues arise. JMeter offers a variety of listeners to help you analyze your test results. The summary report and aggregate report provide high-level overviews, while the view results tree and response time graph offer detailed insights. Choosing the right listeners for your test helps you focus on the metrics that matter most for your application. Correlation is a technique used to capture and reuse dynamic values, such as session IDs or tokens, from previous responses. This is especially important for applications that generate unique values for each session. By extracting these values and using them in subsequent requests, you ensure your tests remain valid and realistic. After running your tests, it's time to analyze the results. Focus on key metrics like response times, error percentages, and throughput. Use the summary or aggregate report to identify spikes or bottlenecks, and review response charts to spot trends. This analysis helps you understand how your application performs and where improvements are needed. Integrating JMeter into your CI/CD pipeline automates performance testing and ensures your application meets quality standards with every deployment. By running JMeter in command line mode and connecting it with tools like Jenkins or GitHub Actions, you can trigger tests automatically and publish reports for every build. JMeter tests often reveal common bottlenecks, such as slow database queries, memory leaks, unoptimized APIs, limited thread pools, or network latency issues. By identifying and addressing these problems early, you can significantly improve your application's performance and reliability. To make your tests more efficient, it's important to optimize JMeter's resource usage. Running tests in non-GUI mode, disabling unnecessary listeners, and using backend listeners for data export can help reduce memory and CPU consumption. These practices ensure your tests run smoothly, even at scale. It's important to distinguish between response time and transaction time in your tests. Response time measures how long a single request takes, while transaction time covers the duration of multiple requests grouped as one logical flow. Understanding both metrics helps you evaluate user experience more accurately. Recent versions of JMeter have introduced several enhancements, including improved HTML reporting, better support for distributed mode, and compatibility with new HTTP protocols and JSON assertions. Staying updated with the latest features ensures you get the most out of your testing efforts. Let's walk through the basic steps of setting up a load test in JMeter. First, add a thread group to define your users, ramp-up period, and loop count. Next, add an HTTP sampler to specify the API or web endpoint you want to test. Then include a listener such as the summary or aggregate report to collect results. Finally, run your test and monitor the response metrics to evaluate performance. Imagine you're testing an e-commerce site. You can simulate 500 users browsing products, adding items to their carts, and checking out. By using timers to introduce think times and random CSV data for user actions, you create a realistic load. This approach helps validate throughput and response time under peak conditions, ensuring your site can handle real-world traffic. Running JMeter in non-GUI mode via the command line is essential for CI/CD integration. By using commands like JMeter N, test plan, JMXL results, JTL report, you can automate test execution. Integrating with Jenkins and its performance plugin allows for automatic report publishing, making performance testing a seamless part of your deployment pipeline. Tracking the right metrics is crucial for meaningful test results. Focus on response time, average, minimum, maximum, throughput requests per second, error percentage, percentile response times 90th, 95th, and transactions per second. These metrics provide a comprehensive view of your application's performance and help you identify areas for improvement. During performance testing, you may encounter several common bottlenecks. These include slow database queries, memory leaks, network latency, server thread limitations, and API timeouts. Identifying these issues early allows you to address them before they impact your users, ensuring a smoother experience. Let's look at a practical example of correlation. Suppose your application generates a session token after login. You can use JMeter's regular expression extractor to capture this token from the response, then reuse it in subsequent requests using a variable like token. This ensures your test flows mimic real user sessions accurately. Parameterization is another key technique for realistic testing. By reading dynamic usernames or other data from a CSV file using the CSV dataset config, you can ensure each virtual user behaves differently. This approach increases test coverage and helps uncover issues that only appear with diverse input data. Analyzing your test reports effectively is vital for actionable insights. Use the aggregate report for a quick summary and the HTML dashboard for visualizing trends over time. Pay special attention to error percentage, average response time, and throughput to identify areas that need optimization. Following best practices ensures your JMeter tests are reliable and efficient. Always run large tests in non-GUI mode, use distributed testing for scalability, warm up the server before testing, keep your test data realistic, and monitor both client and server metrics. These habits help you get the most accurate and useful results. Take your testing to the next level. Consider integrating JMeter with advanced tools. Grafana and InfluxDB provide real-time dashboards, Jenkins automates your testing workflow, and cloud-based platforms like BlazeMeter or Octoperf enable large-scale distributed testing without local hardware limitations. Looking to build your portfolio? Try a project like performance testing of REST APIs for an online store using Apache JMeter. This project should include a detailed test plan, well-documented scripts, and a comprehensive analysis report. It's a great way to demonstrate your ability to design, execute, and analyze performance tests in a real-world context. Configuring your thread group correctly is the foundation of a successful JMeter test. Set the number of users, define the ramp-up period, and specify the loop count based on your testing goals. Adjusting these parameters helps you simulate different traffic patterns and stress levels for your application. HTTP samplers are used to define the specific API endpoints or web pages you want to test. By configuring different samplers, you can simulate a variety of user actions, such as browsing, searching, or checking out. This flexibility allows you to tailor your tests to match real user journeys. Listeners are not just for collecting data, they're also powerful tools for analyzing and visualizing your results. Choose listeners that align with your testing objectives, and remember to disable unnecessary ones during large tests to save resources. This approach keeps your tests efficient and your reports focused. Once your test plan is set up, run your tests and closely monitor the response metrics. Watch for spikes in response time, increases in error rates, or drops in throughput. Real-time monitoring helps you catch issues as they happen and make adjustments on the fly. Get the most accurate results. Design your tests to mimic real-world scenarios. Use timers to introduce think times, parameterize user data, and simulate a variety of user actions. This approach ensures your tests reflect actual usage patterns and provide meaningful insights. As your testing needs grow, distributed testing becomes essential. By connecting multiple machines, you can simulate thousands of users and generate significant load. This scalability is crucial for testing high-traffic applications and ensuring your infrastructure is ready for anything. Jenkins integration streamlines your testing workflow. By automating test execution and report generation, you ensure consistent performance checks with every deployment. This not only saves time, but also helps maintain high quality throughout your development lifecycle. Grafana dashboards provide real-time visualization of your test metrics. By integrating JMeter with Grafana and InfluxDB, you can monitor performance trends as tests run, quickly spot anomalies, and share insights with your team. This level of visibility is invaluable for proactive performance management. Cloud-based platforms like BlazeMeter and Octoperf make it easy to run large-scale JMeter tests without worrying about local hardware limitations. These services offer scalability, easy integration, and powerful reporting features, making them ideal for enterprise-level performance testing. In building a portfolio project, focus on clarity and completeness. Document your test plan, include sample scripts, and provide a detailed analysis report. Highlight your ability to design realistic tests, interpret results, and make actionable recommendations based on your findings. Performance testing is an ongoing process. Regularly review your test plans, update your scripts to reflect new features, and refine your metrics as your application evolves. Continuous improvement ensures your tests remain relevant and your application stays performant. The world of performance testing is always evolving. Stay updated with the latest JMeter releases, new plugins, and best practices by following official documentation and community forums. This proactive approach helps you leverage new features and stay ahead in your career. Congratulations on completing this comprehensive JMeter interview and preparation guide. You now have a solid understanding of JMeter's core concepts, practical testing techniques, and advanced integrations. Use these insights to ace your interviews, deliver robust performance tests, and drive continuous improvement in your projects. Keep practicing, stay curious, and you'll be well on your way to becoming a JMeter expert.